This is a Notes app. Create one, edit it, delete it. Simple. What matters is where it runs. This is Oracle Cloud, top to bottom. A static site, an API gateway, serverless functions, a NoSQL database, no servers anywhere. I built this exact app on AWS first, then ported it to OCI to see how close the two clouds really are. And it works. Everything you're seeing is live on Oracle. But getting it there. A few things were genuinely disappointing. Let me show you. Here's what we're building. A serverless Notes app on Oracle Cloud. The front end is static files in an object storage bucket served as a website. No web server. Every action is just a call to the API gateway. The API gateway is a single front door, mapping each route to the right function. Each route is its own OCI function running Python, one per operation. They're serverless. They spin up on a request and cost nothing when idle. Function code is packaged into a Docker image, pushed to OCIR, Oracle's registry, and pulled when the functions run. The notes live in a managed NoSQL table, nothing to provision. Access comes through a resource principal, so there are no keys in the code. The whole project is one public repo on GitHub. Clone it and follow along. First, a quick environment check confirms the tools are in place, the OCI CLI, Terraform, and Docker, and that we're authenticated to Oracle Cloud. The apply command creates the entire deployment in one shot, builds the Docker image, pushes it to OCIR, then Terraform provisions the rest. The NoSQL table, the 5 functions, the API gateway, and the object storage bucket for the front end. No console clicking. When it finishes, a validation script exercises every route. Create, list, get, update, delete across 5 test notes, and prints the live API and website URLs. Why does a serverless app need a container registry at all? Because OCI functions don't run your code directly, they run containers. So the image has to live somewhere first, and that somewhere is OCIR. There's the one we built and pushed. And here are the 5 functions. Create, list, get, update, delete. Every one running that exact same image. One container, 5 endpoints, all active. The API gateway ties them together behind a single live endpoint. The URL the web app is calling. And the front end is just a public object storage bucket serving index.html. Every box from the architecture diagram now up and running. So it all works. But run it for real, and OCI serverless starts to disappoint. OCI's cold starts aren't a little slower than Lambda's. They're an order of magnitude slower. And the reason goes right back to the architecture. Because OCI only runs containers, every cold start has to pull and boot an entire Docker image, where Lambda just spins up your code. Now there's a fix. Flip on provision concurrency, and OCI keeps your functions warm for those fast sub-second starts. But there's a catch. You can't warm just one. The minimum is 10 per function, so staying fast costs server prices, not serverless. To be fair, at scale OCI with provision capacity can actually come out cheaper than AWS. The real difference is that on AWS, most small apps don't need provisioning at all. The cold start is fast enough to live with. In the end, this is why OCI serverless is so disappointing. Everything you saw is up on GitHub, the Terraform, the functions, and the web app, all in one repo. Clone it, and you can stand the whole thing up yourself. And when you're done, the destroy script tears it all back down in one shot, so you're not left paying for anything still running.